Okay, so what we've canceled out is a factor. He called it the greatest common factor, which is absolutely correct. For 24 and 56 is 8. And we cancel out that greatest common factor. What we're getting into today is, well, what if it's not a normal fraction like numbers? What if it's got letters and it's got a polynomial and stuff like that? It's still the same idea. You're thinking, okay, I want to cancel factors. We don't cancel terms, we cancel factors. Like 24 could be written as 20 plus 4, right? But we don't cancel that way. We cancel with factors. Factors are things that are multiplied together. So that's the key, is you can't cancel pieces that are not multiplied together. You can only you have to have multiplication to go from there. So let's kind of build into that idea. If we had 12x squared over 16x, well, how does that simplify? Well, how does 12 over 16 simplify? Just if don't even worry about the x's yet. Be 3/4, right? 4 goes into 12 3 times, and into 16 4 times. So that's 3 over 4. Now, how about the x's? Well, that's x squared is how many x's? 2 of them. There's 1 on the bottom. So that's going to cancel out 1 on the top with the 1 on the bottom. So we're just left with the x up here at the top. So we're canceling out factors there. They're factors because they're multiplied together. Where it gets a little bit more interesting is when we start building into the polynomial idea, and we'll start with one that's already factored for us. Maybe we got 3x and then x plus 4 over x plus 3, x plus 4. So here we have factors on the top of 3x and x plus 4, and the factors that are on the bottom are x plus 3 and x plus 4. Which factor is going to cancel? Yeah, this x plus 4 on the top cancels x plus 4 on the bottom. And you're left with 3x over x plus 3. We can't cancel the 3 or the x on the bottom with the ones on the top because these are multiplied together. These are not multiplied together. Remember, factors are only things that you can cancel. So they have to be multiplied together to be factors. This x plus 3, they're not factors, they're sums. So that you can't cancel individual pieces, just whole factors. Now let's get to more Algebra 2 level. X squared minus 2x minus 15 over x squared minus 9. So here's one that's got a trinomial on top and then a binomial on the bottom. But we're asked to simplify that. And anytime you have polynomials, top and bottom, or just it doesn't matter where they're at. If they're polynomials and you're asked to simplify, the name of the game is factor. You want to factor everything. Okay, so let's factor the numerator first. How does that factor? So the x method be negative 15 and add to be negative 2. What are my two factors for that? Negative 5 and 3, so that'd be x minus 5, x plus 3. How does the denominator factor? Yeah, x minus 3 and x plus 3. And then we cancel factors. So what factor cancels? All right, the x plus 3 cancels the x plus 3, and you're left with x minus 5 over x minus 3. The most common mistake I see in Algebra 2 or Algebra 1 where we do this, or college algebra even, is folks want to say, oh, this x cancels that x. They do not, because these are not factors. They're differences, sums. It has to be multiplication. See how these factors are multiplied together. That's why you can cancel. You can cancel factors, things that are multiplied. You can't cancel things that are not. All right, so let's go a little further. Maybe another one that's similar to that. Say we had x squared minus 8x plus 16 over x squared plus 2x minus 24. So again, some trinomials here. Not getting too difficult with the factoring. making sure you get the idea of factor everything and then cancel out the pieces that do. Okay. So how does the top, or what are the factors that the top part or the numerator becomes? Multiply to be 16, add to be -8. -4, so that's x minus 4, x minus 4. You could write that as x minus 4 squared if you wanted to. It doesn't necessarily help you or hurt you either way there. What about the denominator? 6 and -4, so it'd be x plus 6, x minus 4. How many of the x minus 4s are going to cancel? One on top and one on bottom. Doesn't matter which one of the ones on top you cancel. Just one from the bottom cancels one from the top. And you've got a simplified rational expression. Throw this one out there. Let's make that 40x squared at 20x, and then 10x plus 30 on the bottom. For whatever reason, this one seems to be one that folks just forget how to factor. What do we do? Why 20x? GCF of that top part is 20x. Leaves what inside? X plus 1. On the bottom, GCF is what? 10. And leaves x plus 3. Now, this one's a little bit more difficult, or it's easy to factor. GCF's a pretty easy way to factor, but it doesn't look as simple as far as canceling does as the previous problem does, right? Where's the cancellation happen at? Yeah, the 20 and the 10 can cancel there. They're factors. So 10 goes into itself one time and then the 20 two times. So we're left with 2x, parentheses 2x plus 1 over x plus 3. You can put the parentheses. You don't have to on the bottom. Have to have them on top, not on the bottom. And we're not going to multiply back out the top here while we're simplifying. When we go to add and subtract polynomials Thursday, we'll have to do some more stuff for that. But simplifying, just leave them in factor form, so with me. Okay. All right. Let's do another. Well, gee. Let's do x plus 4 over x cubed plus 64. It's a fun one. Makes us remember something maybe from polynomials. And that's the key here. If they remember some things from the past. So does the top part, does the numerator factor in? No, it's pretty obvious it does. You don't see an exponent on the variable and it doesn't have a GCF, you're good. What about the denominator? Almost got it. One more piece. Plus or minus 16? Plus. Difference of, or sum of squares, or sum of cubes, not squares. Sum of cubes there. That's 64 is 4 to the third power. Remember, the short piece has the same sign. The long piece changes it in the middle. It's always a plus on the end. Okay? If you use 1 4 here, there's 2 left over for there. Use 1x there, there's 2 left for there. You get the middle piece, you multiply these things together. Okay, and then on the top we still have the x plus 4, and that allows you to cancel. What's the numerator of this final answer? 1. If everything cancels out, it's a 1 left over. And there's our simplified or rational expression. Not too bad. So we had 5x squared minus 10x minus 15 over 2x squared minus 2x. Why my 2's are not looking like 2's? Minus 12. So what's the first thing that we do? GCF. What's the GCF on the top? 5. That leaves x squared minus 2x minus 3. The bottom, the GCF's a 2. And then, will those trinomials factor? What's the numerator then? Oh, it's got the 5. Then what are the 2 pieces? I'll go ahead and, the bottom one does too. So what are my 2 factors in the numerator? X minus 3 and x plus 1. And in the denominator, yeah, x plus 2 and an x minus 3. No matter what order you write those in, just get them there. And then we cancel out everything that'll cancel. Not much that cancels here, but it's a very important piece. That x minus 3 cancels out. So we're left with 5, x plus 1, 2, x plus 2. So it does simplify some. There, gets rid of a factor. The 5 and the 2 just kind of hanging out there. They're not really doing anything else. Okay. Questions so far? Not an incredibly difficult thing, just simplifying. Let's go. Let's get one more simplifying. And then we'll move. We're going to multiply and divide as well today. All right, so 2x squared plus 10x over 3x squared plus 16x plus 5. Let's get the factored form of the numerator and the denominator here. So in the numerator, what's it going to be? That's the easy one. 2x and x plus 5, right? The denominator is a little bit more difficult because it's not a shortcut trinomial. Yeah, 3x plus 1 and x plus 5 is the correct way of factoring that. If you did 15, add to be 16, that's 15 and 1. Just reviewing here how to do that. Group. There's your 3x, x plus 5, plus 1, x plus 5. And then that leads to that. And then cancel out the matching factor. You've got your simplified expression. A lot of factoring going to be involved in what we're doing today. It's just, it's the muscle that goes with it. So, all right, let's look at multiplying fractions. And let's start with an example of just regular numbers so we remember our rules about multiplying fractions. Okay. Find the product. Remember, product in math is just a real mathy word to say multiply. So we're on J. 3 over 28 times 21 over 18. So two just simple fractions that we would be multiplying together. And so let's talk about the rules and the things that you can do that are legal mathematically in order to multiply these fractions, ways that can make it easier. What's one way to do it? Anybody remember what you could do? What's that called? I know what you're doing, but what's it called? Cross canceling is what that's called. So Trevor's saying we can take this 3 and say 3 goes into itself 1 time, 3 goes into 18 6 times, and then the 21 and the 28 are divisible by 7. You can divide those by 7. You can cross cancel. And that's a very good way of doing it. Okay? When you're dealing with multiplying fractions, cross canceling diagonally and vertically are equal ways of doing that. Okay, you can do that to help your cancellation process. So Trevor said this is a 1, this becomes a 6, this is becoming a 7, and this becomes a 7, becomes a 3, and this becomes a 4. But then we have a 3 on top and a 6 here. So that's the vertically that we could, it's a normal fraction there. It's 3 over 6. We could reduce that to 1/2. And then what do you do? Once you've done all the cross canceling, what do you do next? You multiply straight across. 1 times 1, 1. 4 times 2, 8. That's one way of doing it. Another way of doing it is to just multiply first and then simplify. And some of you may have done it that way your whole lives, and it's absolutely fine. Depends on who you had teach you this the first time, which way you did it. Okay, that seems to be what I've gathered is whoever taught you how to multiply fractions first gets to decide how you probably will live in the rest of your life. I don't know why that's the way it is, but it's kind of like your first boyfriend will always be who you compare everyone after. It's true. Don't act like it's not. And guys, your first girlfriend, that you'll compare her, everybody else to her too. So. All right, 1. And all right. So if we do it that way, it's a more difficult process, right? Because you got to multiply 3 times 21. Just isn't that difficult. It's 63. But 28 times 18, that is much more difficult, right? So multiplying straight across first, probably not the best way when we go to adding polynomials to the thing. Okay, so we want to utilize this cross canceling idea throughout the day, really. So let's get a problem that's got some letters in it, because that's the fun part. Math's not fun unless it's difficult. This is probably not very much fun for some of you. Okay. All right. And so remember, what are the rules for cross canceling? Vertically and diagonally. Never straight across. Always either vertically or diagonally. Okay, so I always look for vertically first, because that just focuses me on individual fractions. So if I look at the first fraction, 8 x to the 5th y over 2xy squared, what about the 8 and the 2? They can cancel, right? 8 becomes a 4 and 2 becomes a 1, right? And then what about the x's? You got 1x, 5x's up top and 1 on the bottom. So this 1 right here is going to cancel how many of those? It's going to cancel 1 of those, so it'll be 4 left, right? So that turns into x to the 4th. So this guy's gone. This guy becomes x to the 4th. It gets a little messy doing it this way, but I think it makes it a little easier than if you multiplied it straight across. What about the y's? Got 1 y up top and got how many on the bottom? 2. So this 1 cancels how many of those? 1 of those. So this guy's gone, and this guy becomes y to the 1st. Now I'm going to do the same thing over here on this fraction. I'm going to go vertically. 7 and 4 don't work, right? Nothing to do there. Got x to the 4th on the top. No x's on the bottom. So nothing to do there. But here I have a y cubed and a y. So this y turns that into y squared. Yeah, y to the 2nd. So this one's gone. This becomes y squared. Once I do vertically, then I do diagonally. That's not a rule that you have to do vertically first. If you want to mix and match, if you see something diagonally that'll cancel, it doesn't matter. It's multiplication, so the order that you do things doesn't matter. It's commutative, meaning you can do it in any order you want to, and it still works out. Okay? So, got a 4 here and a 4 here. They cancel each other. I got a y down here and 2 y's up here. So there's 1 left up there in the top. And that looks like everything that's canceled. But I've got an x to the 4th left here, a 7, and another x to the 4th. What happens when I multiply straight across there? I add exponents. Good job, guys. X to the 4th and x to the 4th makes x to the 8th. There's a 7 on the front and 1 y left. What's left on the bottom? Nothing. There's 1. Because everything, look here, everything on the bottom is canceled out. So there's nothing there. Technically, there's a 1 there, but dividing by 1 is understood when you write it that way. Now, one like this, if you wanted to multiply straight across first and do it, that would work. You would still get the same answer. That's the beauty of this stuff, is that you can do it multiple ways and still everybody gets the same answer. But it's also one of the confusing parts, is that your buddy may do it one way and you do it another way, and you still got the same answer, but who's right, who's wrong? Well, technically, neither of you are wrong, because it can be done in different orders. Let's get another one of those, because I think these are more difficult than the ones where you actually have to factor and do. So 5x squared y cubed 3x y to the 4th times 27 x to the 5th over 15 x to the 4th y. I'll give you a second here to do that one on your own and see if we can all get the same answer. What's the time here? Do it in kind of whatever order you feel like. All right, has anybody got an answer? What you got? Anybody that's got one? Just 3x squared over y squared. Anybody else get that? Yeah, got a few others that got that. All right. Somebody got an answer but didn't get that. Don't have to raise your hand. Let's go through how that happens, okay? So, again, my style of doing it is vertical first, then diagonal. I don't know why I do it that way. I guess it's because Miss Campbell that I had for all my high school math classes. Y'all know Miss Campbell. Yeah. Yeah, she was my high school math teacher here, so back in the day. So vertical first, x and x squared. This x cancels one of those. So that becomes x to the first power. And then this y to the third cancels three of those. So that's y to the first power on the bottom. And then I'm across, over here, I got an x to the fourth and an x to the fifth. This guy cancels all but one of those. And then I can then go diagonally 5. And then that'll actually go a little bit further. I should have done the 27 to 15 by 3, I guess. And there's the 3. There's an x and an x. That's x squared. Here's 1 times 1 is 1. And then we have 1 y to the first, and y to the first is y squared. How about that? Honestly, I think this type of problem is more difficult than what we're about to do. The ones where you got to factor. I think the factoring ones are much more straightforward as far as canceling goes. Let's look at some of those so we can move on to division. Just as easy. X squared plus 8x plus 16 times x squared minus 16 over 5x. So, again, when you get this problem where they've got all these polynomials in all the different places, the key to being able to do this is just factoring everything. Anything that'll factor, factor. Because we're finding the product, but we're simplifying. If you multiplied straight across first, this is like that 28 times 18 idea that's a much more difficult problem than 2 times 21 or 3 times 21 would be. Okay, so multiplying straight across, you definitely don't want to multiply x squared plus 4x times x squared minus 16. Y'all remember multiplying out those polynomials that had certain zeros and how difficult that could get, how many places you could make a mistake. And then you got to break it apart anyway. So let's simplify by factoring first. So the top part of the first fraction factors is x plus 4 and x. The denominator of the first fraction would be x plus 4 and x plus 4. The second fraction, what does x squared minus 16 factor as? Ooh, I know. It's x plus 4 and x minus 4. Thanks for answering, Mr. Isbell. Good job. All right. Now, once you get everybody factored, it's just canceling the matching pieces vertically and diagonally. Okay, so vertically, we've got an x plus 4 and an x plus 4. On the second fraction, I don't have anything vertically. So then I go to diagonally. I've got an x and an x. So they're going to cancel each other. I like to circle them and cancel those because they're small. And crossing out x's is tough because it looks like I just put another line on the x. And then we have diagonally x plus 4 and x plus 4. Final answer is what's left over. Nothing here. That's gone. That's all that's left is x minus 4. Gone, gone. The x is gone. 5 is all that's left. We've got a much simpler problem than what we started with. Simplified. Okay. All right. Now, let's get maybe a little bit more difficult problem. 20x minus 5x squared over x squared minus x times x squared plus 3x minus 4 over x squared minus 16 again. That one. One of these things is not like the other. One of these things just doesn't. Y'all ever watch Sesame Street? One of these things just doesn't belong. All right, so what's wrong? Which one's not like the others? Top left, that's right. It's not in descending order, is it? So when we're factoring, we want things in descending order, right? That makes it easier. So let's rearrange it. So that's negative 5x squared plus 20x. Okay. And then factor everything from there. I'm gonna give myself enough room here. So I'm gonna, yeah, I did. How do we factor the numerator of the first fraction? Top left. When I pull out the GCF, what am I pulling out? Negative 5x. That'll leave you x minus 4. That's one of the keys to this particular problem, and it's kind of a trick that they try to throw in there where you've got to pull out a negative to make the factors match up. And if it's in descending order, that makes it a lot easier to recognize that happening. The denominator would be x and x minus 1, right? Second fraction, how's it factor? X plus 4, x minus 1. Good job, Molly. What's the next one? Yeah. And just go to canceling stuff. The sound effects help. Do that. Makes it more fun anyway. What's left? Man, all that junk they had originally, but that's really just negative 5. That's negative 5. Where's the mystery, man? There is a mystery. There's a machine in Scooby-Doo that's a mystery machine. But, all right, let's do this one. X plus 2 over x cubed. Nobody else got that conversation at all. Maybe Juan did, but he's not going to let anybody know he did. The mystery machine, it was the van. You didn't know that? You're going to bring up Scooby-Doo.
Apparently, all the high school teachers know that's mystery Wood sings that song.
We grew up on it. I grew up on SpongeBob. We grew up on Sesame Street.
I used to watch Sesame Street too, but that was like.
Bozo the Clown. Y'all scared of clowns. We grew up watching them in the mornings when we got to school. We got off the bus, you went to the change room, and you sat there and watched Bozo the Clown. He had cartoons, and then they played games and stuff like this. He looked like Pennywise the Clown. All right, let's look at this one. This one looks weird. Why does it look weird? Because I don't have a fraction in the second one, but I can make it a fraction by doing what? Put it over 1, yeah. So if your OCD is killing you, you got to make that a fraction. You can do that. You could, but if you put a 5 on the bottom, you got to put a 5 on the top and multiply it to everything else. So the answer to that is no. It wouldn't be mathematically legal to put a 5 in the bottom and not in the top. All right, so what do we do here? Well, we remember how to factor a difference of cubes, hopefully. And how do we factor a difference of cubes when it's x cubed minus 3 cubed? How does that factor? Because I know this x plus 2 doesn't factor at all. But what are the factors for that difference of cubes? X minus 3.
X squared minus 3x, y minus x squared plus 30x.
Is it what? What was the last piece?
Minus 9.
Close.
What is it?
It's always a plus. Always a plus in the third spot. Third spot's always plus. Third time's a charm. Always a plus in the third spot. Maybe that helps you. All right. Now, what about this trinomial here? Is there anything that multiplies b9 and adds b3? No, it's not. I hope you don't think there is. So that trinomial doesn't factor. And it turns out that it's the same as that trinomial that's down here. Like you set the problem up that way. So what cancels? That and all of that over there. That whole piece is the factor that cancels that whole piece. Even though it's a trinomial, that's mathematically legal, that if this matches all of that, then it can cancel all of that. It's like you made these problems up sometime. And good job. X plus 2 over x minus 3. That 1 really doesn't matter. Okay. Not bad, not bad. Pretty good, pretty good. This example brought to you by the letter P. X cubed plus 8 over x minus 2. X squared minus 4. X squared minus 2x plus 4. Now, solidify this idea. Speaking of Sesame Street, they got a new Muppet coming out. She's got autism. So that's a neat thing. Pretty cool.
You make a Muppet with autism.
There's actually a lot that goes into them making a new Muppet for Sesame Street, because they try to mimic characteristics of this thing with autism. Is what's so groundbreaking about it, because autism is so hard to pinpoint particular parts.
There's a lot of different kinds of autism.
Exactly. If you've met one kid with autism, you've met one kid with autism. They're all different. So they did a lot of research and tried to find maybe the most common characteristics, and that's what they're going to bring. Kind of help kids learn how to deal with their classmates. I think it's phenomenal.
Do the Sesame Street people call the Muppets?
The Muppets are Jim Henson's thing, which Jim Henson designed the model for the Sesame Street show. So the Muppets movies and all that are spin-offs of Sesame Street. They all started on Sesame Street. I'm recording that, so maybe it helps me understand something. All right, let's see if we can figure this one out. It looks kind of innocent. Maybe it's not. Hopefully you can get to where you're getting to where you can do this pretty quickly. Get the factored forms of all those. Check your factored forms with mine. Make sure mine are right. It's pretty close. I'm going to say good enough for government work. What cancels? Okay, so both of the x plus 2's are left. Is that what you're saying? Yeah. That cancels that. This cancels this. So that would be x plus 2, and you could write it squared. That's how I would write that. Yeah. You know, you only do part of the job if you do good. It is. I work for the government, so you know. And technically, since you do work for me, you do too. Mm-hmm. Mm-hmm. All right, let's look at division. All right, just a few more examples, guys, and we'll be done for the day. All right, division, dividing fractions, and this is where you just gotta pull back some. You know, you hadn't divided fractions probably without a calculator in a while, because you've got that nice calculator that you've had for since you were in the 4th grade, unfortunately. And you just type them in the calculator and it gives you the answer, and you don't ever question why that's the answer or anything like that. So how is it that you manually do it? Flip which one? Second one. And then what? 12 over 25 times, not 4 over 5, but 5 over 4. And then it becomes a multiplication problem again, which we've already done a bunch of those, right? 1, 5, 1, 3. That's good. Are you okay?
Yes, sir.
Juan, I'm worried about you, buddy. All right, here's a good problem. He's excited. Yeah. All right, so we got a division problem here. We got 7x over 2x minus 10 divided by the fraction x squared minus 6x over x squared minus 11x plus 30. Don't be lazy and not flip the second one and rewrite it. I've seen too many people that are really good at factoring miss problems by doing that. Okay, so like when you look at this in the book, I probably would never. I probably, if I'm doing problems in the book, out of the book today or tomorrow, I probably never write the division problem now. I'll write it as a multiplication problem the first time. I've seen too many people that write it as the division problem and then say, "Oh, I know I'm flipping it," and they don't flip it, and they forget that they're flipping it. So they flip and miss it because they didn't flip it. A lot of flips in there. More flips than a Russian gymnast. Here we go. All right. So this is how I would, I'd see that problem in the book and I'd rewrite it this way. I'd see that problem on my test or my quiz and I'd rewrite it this way before I even started thinking about working it. And then I would start doing my job. Yeah. What are you doing on the bottom part then? X minus 5, good. Numerator of the second fraction. Good job. Denominator of the second fraction. That's nice. Now I'll start canceling stuff. Yeah, have ugly stuff to turn into 7 over 2. All right. Questions about division? Flip the second one. Multiply. That's the name of the game. All right. So we're done for the day. Your assignment for tomorrow. Oops, not 557, 577. I think we want to do all of those instead of odds. Let's do. Let's do those. All right, guys. 6 through 43. We're gonna do all those. Decided to just do them all. You got about 36 minutes left in class today, and you'll have all day tomorrow to work on these and ask questions. And then we'll quiz on Thursday, and then do the adding beginner's assault on adding and subtracting the next day. I mean, on after the quiz on Thursday. An assault. That is, unless the government bans assault factory and assault factory. That's a joke.